define harmonic mean, consider the following set of values. Our set of data consists of the values x1, x2, x3, up to xn. Or in compact notation, we write our set of values consists of x of I, where I is 1 to n. And the harmonic mean of this set of values is defined as the number of values divided by the sum of the reciprocals of these values in the given set of data. In symbols, we denote the harmonic mean by capital H, and harmonic mean H is equal to n. N is the number of values. We have 1, 2, 3, up to n. And values in the given set of data divided by the sum of the reciprocals of the set of values. We take the reciprocal of each value. Reciprocal of x1 is 1 over x. Reciprocal of x2 is 1 over x2. Reciprocal of x3 is 1 over x3 up to the last nth value. Its reciprocal is 1 over xn, and we add the reciprocals of the values in the given set of data. And n divided by the sum of the reciprocals of the values in the given set of data defines harmonic mean. In compact notation, the sum of the reciprocals can be written in compact notation using the sigma notation for summation. So the divisor can be written in more compact way as the summation of 1 over x of I, where 1 over x of I is the reciprocal of the ith value in the given set of data, where I is 1 to n. Now, from here, if we divide the numerator and denominator by n, we would get this one. N divided by n is 1. And the sum of the reciprocals of the values in the given set of data, we divide by n. And using compact notation, the sum of the reciprocals of the values in the given set of data can be written as the summation. Using sigma notation, the summation of 1 over x of I, where I, the subscript I, goes from 1 to n. And you can see that this denominator summation of 1 over x of I divided by n is the average of the reciprocals of the values in the given set of data. Now, if you take the reciprocal of this, 1 over the average of the reciprocals, we would get this formula for computing the harmonic mean, n divided by the sum of the reciprocals of the values in the given set of data. Thus, the harmonic mean is also defined as the reciprocal of the average of the reciprocals of the n values in the given set of data. We now take one example for computing harmonic mean. Consider the following problem. Example 1. Find the harmonic mean of 3, 7, 8, and 400. In this given set of data, we have 4 values. So our n is 4. And our harmonic mean, denoted by h, is equal to 4 divided by the sum of the reciprocals of these 4 values. Reciprocal of 3 is 1 over 3 plus sum is indicated by the operation addition. Reciprocal of 7 is 1 over 7 plus the reciprocal of 8 is 1 over 8 plus the reciprocal of 400 is 1 over 400. And we compute this value directly from your calculator. We have 4 in the numerator. 4 divided by 1 over 3 1 divided by 3 plus 1 over 7, that's 1 divided by 7, plus 1 over 8, that's 1 divided by 8, plus 1 over 400, or 1 divided by 400, and you should get 6.6259. 6.6259 12048 9055. Now we round up the answer to 2 decimal places. That means we round up the third digit from the decimal point. From the decimal point we count 3. We have 1, 2, 3. The number to be dropped is 5. Since 5 is exactly 5, we add 1 to the preceding digit 2. And so 2 plus 1 is 3. And the harmonic mean of the set of 4 values, 3, 7, 8, 400 to 2 decimal places is 6.63. That's the harmonic mean. Consider again the set of 4 values, 3, 7, 8, and 400. Suppose we compute the arithmetic mean or the sample mean for this set of data, denoted by x bar. X bar is given by summation of the values, denoted by x, divided by the number of values. We get the summation of the values. The values are 3, 7, 8, 400, and we add these 4 numbers. 3 plus 7 plus 8 plus 400 all over 4. And we use again our calculator to find this value. We have 3 plus 7 is 10, plus 8 is 18, plus 400 is 418. And we divide 418 by 4. Divide by 4 equals 104.5. Now, using the arithmetic mean or sample mean x bar, we get a value of 104.5, which is very much greater than the harmonic mean of 6.63, because the mean is said to be biased towards large value. Hence, the harmonic mean is a type of average that is good to use when the set of values or the set of data contains outliers, such as 400 is an outlier because it is extremely large compared to the other values in the given set of data. And this 104.5 arithmetic mean seems not to be so realistic, because in this set of data of 4 values, most of the values are small. And that is one disadvantage of the arithmetic mean when you add the values that contain extremely large or extremely small values. The mean value is affected. If there is an extremely large value in the set of data, this extremely large value or outlier tends to pull up the mean. And if there is an extremely small value or an outlier, this extremely small value tends to pull down the mean of the values in the given set of data. Now, suppose we compute the geometric mean of the set of 4 values. Because we have 4 values in this set, the geometric mean would be the 4th root of the product of 3, 7, 8, and 400. The geometric mean is denoted by G. And for our example, for the set of data with 4 values, the geometric mean is the 4th root of the product of these 4 numbers, 3 multiplied by 7 multiplied by 8 multiplied by 400. And please use your calculator to find this value. We have 3 multiplied by 7 multiplied by 8 and multiplied by 400. And we take the 4th root of the product, or you raise the product to the power 1 over 4. 1 divided by 4. And you should get 16.100, 1006, 1006, 09551, 5517006. Our harmonic mean is 6.63. Our geometric mean, we round up to 2 decimal places. After the decimal point, we count 3, 1, 2, 3, and the digit to be rounded up is 6. From the decimal point, we count 3, 1, 2, 3. The digit to be dropped or rounded up is 0. Since 0 is less than 5, we simply drop 0 and all the digits to its right. And we do not add 1 to its preceding digit, 0. Hence, the geometric mean is 16.10 to 2 decimal places. 16.10. And our arithmetic mean is 104.5. 104.5. You can see that the arithmetic mean gives the largest average among the three arithmetic, geometric, and harmonic means. And the value of the geometric mean is more than the harmonic mean. And the harmonic mean gives the smallest average among these three: arithmetic, geometric, and harmonic mean. In general, the arithmetic mean is always the largest value among the three means, and the harmonic mean is always the lowest value among the three means. In general, the arithmetic mean is less than equal to the geometric mean. The geometric mean is less than equal to the harmonic mean. And these three means would only be equal if all the values in the given set of data are equal. That's why we have equal here. Arithmetic mean equals geometric mean equals harmonic mean. That happens only when all the values in the given set of data are equal. But in general, the arithmetic mean is always the largest value in the given set of data. This should be greater than. The geometric mean is greater than the harmonic mean. Now, this is correct. The arithmetic mean is greater than equal to the geometric mean. The geometric mean is greater than equal to the harmonic mean. The arithmetic mean is greater than the geometric, both the geometric and the harmonic mean. That is, arithmetic mean is always the largest value among the three means: arithmetic, geometric, and harmonic means. The geometric mean is always greater than the harmonic mean. And this also says that the harmonic mean is always the smallest value among the three means. Among arithmetic, geometric, and harmonic, harmonic is the smallest value. It's less than equal to the geometric mean, and the harmonic mean is less than equal to the arithmetic mean. And these three means, arithmetic mean, geometric mean, and harmonic mean, would only be equal if all the values in the given set of data are equal. Now we take another example for the application of harmonic mean. Consider the following problem. A man travels 10 kilometers at 60 kph, that means 60 kilometers per hour. Then another 10 kilometers at 20 kph, that is 20 kilometers per hour. The question is, what is the average speed of the man? The harmonic mean is usually used in problems involving ratios and rates. And we will solve this. We will get the average speed of the man using harmonic mean. To get the average speed of the man, we get the harmonic mean of the two speed. Speed is a rate, 60 kilometers per hour and 20 kilometers per hour. We will take the harmonic mean of these two, since we have two speeds given, and we take n equals 2. And we take the harmonic mean of 60 kilometers per hour and 20 kilometers per hour. and the average speed of the man is the harmonic mean of these two speeds. Harmonic mean is equal to the number of values 2 divided by the sum of the reciprocals of these two speeds. Reciprocal of 60 is 1 over 60 plus the reciprocal of 20, 1 over 20. And we use the calculator to find this value. We have 2 in the numerator and we divide by 2 by 1 over 60. 1 over 60, that's 1 divided by 60 plus 1 over 20, that's 1 divided by 20. And you should get 30 kph or 30 kilometers per hour. The average speed of the man is 30 kilometers per hour. Now we will check if this average is correct. The formula for calculating distance traveled given the rate or the speed and the time elapsed is given by the following formula. We have distance equals speed or the rate multiplied by time. And from here, we can solve for t by dividing both sides by r or the speed. And r will cancel out from the right hand side. We have t equals distance over r. For the first 10 kilometers, the speed of the man was 60 kilometers per hour. And so, the time traveled or the time elapsed for the first 10 kilometers is distance divided by speed. 10 kilometers divided by speed, 60 kilometers per hour. Or we simplify this fraction. We have the numerator 10 kilometers. We multiply by the reciprocal of the denominator. We have r divided by 60 kilometers. And kilometers will cancel out. And 0 will cancel out. Or 10 over 60 to the lowest terms is 1 over 6. 1 over 6 r. And if you want to convert that to minutes, we multiply that by conversion factor 60 minutes over 1 hour. We have 1 over 6r, we convert to minutes using the equivalent units. 1r equals 60 minutes. We multiply by conversion factor. A conversion factor is a fraction. And we write 1r in the denominator so that R and R will cancel out and we write 60 minutes in the numerator. And R will cancel out, and 60 divided by 6 is 10. 10 minutes. So for the first part of the trip, the man took 10 minutes to travel 10 kilometers at 60 kilometers per hour. Now the man traveled another 10 kilometers at a slower speed of 20 kilometers per hour. For the second part of the trip, the man traveled another 10 kilometers at the speed of a slow speed of 10 kph or 20 kilometers per hour, and we calculate the time elapsed for this second part of the trip using this formula: distance divided by r. 10 kilometers divided by speed 20 kilometers per hour, and we simplify this fraction. Numerator is 10 kilometers. We multiply by the reciprocal of the denominator. The reciprocal of 20 kilometers over r per hour is r divided by 20 kilometers. R divided by 20 kilometers. And kilometers will cancel out. We get 10 over 20. In lowest terms is 1/2 r. T is 1/2 r. It took half an hour for the man in the second part of the trip, and we to travel another 10 kilometers for the second part of the trip, and we convert these to minutes by using these equivalent units, and we multiply this by conversion factor, which is a fraction with denominator 1r. Again, we write 1r in the denominator so that r will cancel out. It will cancel out with the r in the numerator. In the numerator of the conversion factor, we write 60 minutes. R will cancel out. 60 divided by 2 is 30 minutes. For the first 10 kilometers of the trip, the man took 10 minutes to travel the first 10 kilometers at a faster speed of 60 kilometers per hour. For the second part of the trip, the man took longer time, 30 minutes, for the same 10 kilometers because his speed was slower at 20 kilometers per hour. In total, the man traveled a total of 20 kilometers for a total time of 10 for the first 10 minutes for the first part of the trip, plus 30 minutes for the second part of the trip. And we will compute the speed of the man for the total distance traveled of 20 kilometers and for the total time elapsed of 40 minutes. And we should be able to get the same result we obtained for harmonic mean, which is 30 kilometers per hour. Again, for the first part of the trip, the man traveled a distance of 10 kilometers. 10 kilometers. at a speed at the rate of 60 kilometers per hour. And we have computed the time elapsed or the time traveled, and we obtained 10 minutes. For the second part of the trip, the distance traveled was another 10 kilometers. For the second part of the trip, the man traveled at a slower rate or speed of 20 kilometers per hour. That's why he took longer time for the second part of the trip, which we have computed to be 30 minutes or half an hour. For the whole trip, the total distance traveled is 10 kilometers plus 10 kilometers is 20 kilometers. And for the whole trip, we want to find the average speed R. And for the whole trip, the total time traveled by the man is 10 minutes for the first 10 kilometers and 30 minutes for the second kilometers, or a total time of 40 minutes. And we find the average speed using the formula for distance given by the following. Distance equals speed multiplied by time. And we can solve for R from this equation by dividing both sides by T. Cancel T. And this implies R is equal to D over distance traveled divided by time traveled or time elapsed. And our total distance traveled, the total distance traveled by the man is 20 kilometers divided by 40 minutes. Now we convert minutes to R so that our speed will be in kilometer per hour. Using the equivalent units, 1 hour equals 60 minutes. R now equals 20 kilometers over 40 minutes. We multiply this by conversion factor, a fraction whose denominator equals 60 minutes, whose denominator is 1 hour. And we write 60 minutes in the numerator so that minute and minute will cancel out. And we simplify. 20 divided by 40 is 1/2, and 1/2 of 60 is 30. 30 kilometers per hour. Or R equals 30 kph. 30 kilometers per hour. And this is how you check your answer in getting the average speed using harmonic mean. This is the same result we obtained using the harmonic mean. And the advantage of using the harmonic mean is that the solution is shorter and more efficient. For your practice, please try the following exercises. Number 1, a piece of art was bought at 75,000 pesos. The value of the art work increases by 40% a year after it was bought, by 70% the second year, and by 35% the third year. What is the value of the artwork at the end of 3 years? For this problem, number 1, you will use geometric mean. And we had an example for solving problems similar to this using geometric mean. Number 2, find the harmonic mean of each set of data. Letter A, we have 1. The set of data consists of numbers 1, 3, 4, and 6. In letter B, the set of data has 20, 35, 26, and 180. Both sets of data have the same number of values, but in letter B, one of the value is an outlier, which means that it is extremely large compared with the other 3 values, and you will use harmonic mean for number 2. Number 3, a man travels 20 kilometers at 35 kilometers per hour, 30 kph, and then 30 kilometers at 50 kph, or 50 kilometers per hour. What is the average speed of the man? To solve number 3, you will use harmonic mean. And please check your answer using the method I have shown earlier for similar problem, where we get the time elapsed, the time traveled by the man for the first part of the trip, 20 kilometers at this rate, 35 kilometers per hour, and you also compute the time elapsed or the time traveled by the man for the second part of the trip of 30 kilometers with the speed of 50 kilometers per hour. And then you get the total distance traveled, and you get the total time elapsed, and then you compute for the average speed using the distance formula, and see if you will get the same result you will get for computing the average speed of the man using harmonic mean. The 3 means we have discussed: the arithmetic mean, which we have discussed earlier in the lesson before today's lesson, and the geometric mean and the harmonic mean that we have discussed today are known as the Pythagorean means. They are also known as the classic means. If you get the geometric mean of 2 values or 2 numbers, the geometric mean is also known as mean proportional. So don't forget, the Pythagorean means are the arithmetic mean, geometric mean, and harmonic mean. If you have questions about the lesson today, you ask your questions in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan. Thank you for being in my class today.